Okay, so continuing our discussion now, this time we will be talking about the geometric sequence. So if you would remember, when we talk about arithmetic sequence, the pattern that we will see is we are adding or subtracting the same number. In the case of geometric, the pattern that we will see is that we are multiplying or dividing the same number. Okay, and that number that we are always multiplying or dividing is what we call as the common ratio. So for the common difference, we had to subtract the current term minus the previous term. In the case of common ratio, it's going to be the current term, so let's say a sub 4, divide it by the old term, the previous term, let's say a sub 3, okay? So let's take a look at these sequences. So if you're going to observe 1, 5, 25, 125, 625, you can see that we are multiplying by 5, all right? 5 times 5, 25, 25 times 5, 125. So how do we find the common difference? Again, just select two terms, two consecutive terms. So let's have, for example, 25. Divide it by the previous term, which is 5. And so we get the common ratio of 5. All right. How about in this sequence? 4, 8, 16, 32. So again, to find the common ratio, so we can have, let's say, 16 divided by 8. Okay. And that is going to be 2. All right. Now, in this case, let's see, we have a 6, negative 12, 24, negative 48, 96. Okay. So still the same thing. You will notice that, okay, the numeric value is multiplied by 2, if you will notice, but you will see that there's an alternating positive negative answer. So to find that common ratio, you can pick out anything. So let's say we have negative 48 divided by the previous term, which is 24. So this is going to give you negative 2, okay? So remember that the common ratio, if you have a number like this, it means that the pattern that you are seeing is you are multiplying it. If by any chance, when you get a common ratio that is in a fraction form, let's say, for example, the common ratio that you get is, let's say, 1/2, okay? This is true if the pattern that you're seeing is that you are getting things divided by 2, okay? So, for example, let's say the geometric sequence, let's say, is 20, and then 10, and then 5, and then 2.5, and then so on and so forth, okay? So if you take a look at this, we are going to follow the rule for common ratio. This term, okay, so 10 over the previous term, which is 20, and so that will give us a common ratio of 1/2. And you will check that every time you divide 20 by 2, this by 2, you are getting the next number, okay? So if your common ratio is an integer, it means the pattern you see is multiplication. If the common ratio that you get is in fraction form, then it means that you are dividing pretty much, especially if the numerator is 1. So let's take a look at this there. Write the first 6 terms, okay, of the geometric sequence. The first term is 6. Common ratio is 1/3, I should say. So first term is going to be 6. Second term is, so we need 2. So I'll have this come up over here. So 6 times 1/3. So it's pretty much like divided by 3, okay? 6 times 1/3 is just the same as 6 divided by 3. So 6 divided by 3, that's a 2. The third term, 2 divided by 3, we'll leave it as it is, okay? And then you have the fourth term, 2/3 divided by 3, or multiply it by 1/3. So you will get it as 2/9. If you have the fifth term, so again, you multiply by 1/3, okay? You will see it's going to be 2/27. And then the last term, sixth term, multiply again by 1/3, and you will see that's going to be 2/81, okay? So if you have a fraction, pretty much, especially if you have a fraction with a numerator of 1, it is dividing by this number here. But like I said, you can always just use multiplication and keep it in fraction form, okay? So, can we find any term in a geometric sequence? Definitely yes, okay? So if you're going to take a look, if you're going to observe the pattern, any term that we're looking for, we start with the first term, we always multiply it with the common ratio. And when you get the third term, the common ratio gets multiplied to itself. So pretty much you have an exponent here, okay? Because the common ratio gets multiplied again by the common ratio. And you will notice that the exponent is always 1 less than the number of terms that you're looking for. And so the general formula, okay, the formula when we are looking for any term in a geometric sequence will always be first term times r raised to n minus 1. Now, I want to emphasize this, okay? You need to do the exponent first, r raised to the n minus 1, and then you multiply with the first term, okay? I've seen people mistake here. The people's common mistake here is they multiply the AR, the first term and the R, and then raise it to the exponent. Nope, that's not how it is. Should be raise the exponent, use the exponent first, and then multiply, according to PEMDAS. So let's have an example here. We need to find the 8th term. So, okay, a sub n is equal to a sub 1 times r raised to n minus 1. Okay, that's that. We are looking for the 8th term. Do we have a first term? First term is negative 4. And then we need to have our common ratio, which is negative 2. That needs to be raised to what? N minus 1, it's going to be 8 minus 1. Okay, so this is going to be negative 4 times negative 2 raised to the 7th power will eventually become negative 2 raised to the negative 7th power is going to be negative 128. And if you multiply negative 128 and negative 4, it simply means that our answer will be a positive number, and that's going to be 512. So that is how you work with any term of the geometric sequence. So let's have 2 application problems here, just so you know how we can use our arithmetic or geometric sequences. So let's have this problem here. We have company A pays yearly $24,000 and raises $1,400 per year. Okay, so when we say raises, we are adding 1,400 every year. So what is our 24,000? This is our first term. And then since we are adding all the time, then this is our common difference, okay? On the other hand, company B starts with a 28,000 and then the raise is 850. So the question is, which company will pay more in year 10? So we are looking for how much is the payment on the 10th term, all right? So let's have the computation here. Company A, okay, company A, let's have it in blue. The first term is 24,000 plus our n minus 1, which is 10 minus 1, and our common difference is it raises every 1,400. So if you work on this, this is 24,000 plus 9 times 1,400, and this is going to be all in all, in your computation with your calculator, you can use that. By the end of 10 years, company A has a total of 36,600 payment for you. Okay, that's company A. Now let's take a look at B. Oops, sorry. Okay, so in company B, still we're looking for the 10th term. We start with how much? A higher starting value, 28,000, and then again we know it's 10 minus 1, so we'll just use the 9 here, and then our increase every time is 850. So once you plug this into your calculator, you will learn that company B by the end of 10th year has paid a total of 35,650. So looking at this question and answering the prompt, which company pays more in year 10? So you will see that it is company A. Company A pays more in year 10, and by how much? You just find the difference. This is 36,600 minus company B's. That's the difference of their how do you call it, the difference of their pays. So if you do the subtraction here, you will get that this is going to be $950 dollars. That's almost $1,000 difference. So if you're going to choose, you're going to be working with company A. All right, let's have the next one. So here we have your saving. Okay, you save $1 on the first day. Okay, $2 on the second day, okay? $4 on the third day, and so on, okay? So what pattern are we looking here? So every time that the day goes by, how much are we saving? From $1 became $2, then became 4. So we are multiplying by 2, okay? How do we know? Well, according to this next sentence, each day you save twice. Okay, so from the name, from the word twice, it means we are multiplying by 2. Okay, we're multiplying by 2. So what will you put aside for savings on the 13th day of the month? Okay, so because we're multiplying by 2, we know that we need to use the geometric sequence formula. So we have A sub 13 is equal to our first term. What was the saving on the first day? $1. Okay, times what is our common ratio? Well, we know that the word twice already means 2 times. So 2 needs to be raised to what? 13 minus 1. Okay, 13 minus 1. And so this will be 1 times, pretty much we can ignore the 1 since we just will have 2 raised to the 12th power. And if you use your calculator to evaluate what is 2 to the 12th power, that is 4,096. Okay? So on the 13th day, you will be putting away, you will be saving 4,096 already, just for the 13th day. So that's everything about sequence. Thank you.